Welcome dear student to our YouTube channel. Today we will learn the preparation of aldehyde only from two main naming reaction. So let's start. The first method is Rosenborn reduction method. Rosenborn reduction method, and the second one is the first one is Rosenborn reduction method and the second one is Stiffness reduction method. Stiffness reduction method or Stiffness process of aldehyde preparation. These two reduction process mainly belongs to the preparation of aldehyde. So by this method we can only prepare aldehyde, So these two reduction process are partial reduction process. Why this process is called as partial reduction? Partial reduction process. These two above processes are called as partial reduction process as the reactants or the chemicals which will produce the aldehyde does not undergo complete reduction, because on complete reduction of aldehyde or aldehyde upon reduction always produces alcohol. That means, remember one thing, what I have told, these two methods will only result in the formation of aldehyde. So I am just starting from aldehyde, but before that you should remember that the previously any reactant is present which upon participation on reduction process will result in the formation of aldehyde, and aldehyde can be reduced by strong reducing agents or reducing agents, and aldehyde upon reduction of aldehyde through any reducing agents they produces alcohol. That means we know that in the previous classes that alcohol upon oxidation or primary alcohol upon oxidation and dehydrogenation process releases aldehyde. So aldehyde upon reduction will result in the formation of alcohol, that means RCH2OH, but this process will not happen here because here partial reduction will occur. That means this process will be blocked by the reagents which we are going to be learn in this portion, because the reducing agents which are involved during the conversion of the reactant to aldehyde will inhibit this process, that means reduction of aldehyde to alcohol. So we are telling that it is a partial reduction method, because upon complete reduction of a chemical which can produce aldehyde can also produce alcohol, but upon partial reduction process the reaction will stop at aldehyde. So we called it as a partial reduction process, and the two process we are going to learn belongs to partial reduction process. So let's start from the first one, that is Rosenborn reduction method. So moving for the first one, that is Rosenborn reduction. So in Rosenborn reduction method of preparation of aldehyde, what we take? We prefer controlled reduction. That means controlled reduction, I have told the controlled reduction term express that here partial reduction occur. That means partial reduction of the chemicals. Here what the Rosenborn scientist taken the chemical here is acid halide, that is RCOX. RCOX is the reactant which upon partial reduction will result in the formation of aldehyde rather than alcohol. So let's start the partial reduction method here, that is what I have told, because it is the general formula of acid halide, that is RCOX, which acid halide. What I have told is the acid halide which upon reduction or partial reduction by Lindler's reagent. What I am telling? Lindler's reagent or Lindler's catalyst. We can tell it as Lindler's reagent or Lindler's catalyst, who is help in controlled reduction process. That means Lindler's reagent helps the acid halide to directly convert into aldehyde rather than to convert into alcohol. That means here what will happen? The halogen atom of the acid halide will replaced by the reducing agents that have the tendency to release nascent hydrogen. So hydrogen pad will replace the halogen atom, resulting in the formation of the aldehyde. That means here aldehyde will be produced directly from the acid halide without going for alcohol. So this will be the complete process of the Rosenborn reduction. So let's learn in detail about that part. So Lindler's reagent. Here question is, what is Lindler's catalyst or Lindler's reagent? Lindler's reagent is that chemical which is composed of palladium over barium sulfate. Barium has the ionic formula Ba2+, and sulfate has the ionic formula that is SO4 2-, which upon cancellation or due to presence of common factor, they will produce barium sulfate, that is BaSO4, and Lindler's reagent contains palladium over barium sulfate, and thus process is poisoned by, or this chemical also contains poisoned sulfur. Why poison sulfur? You can directly light also sulfur or quinoline, which control the conversion of acid halide to aldehyde, but directly not allows the aldehyde to get converted into alcohol. That means if you take here palladium only, so what will happen? Acid halide can be converted to aldehyde, but this process will be uncontrolled. That means aldehyde will convert into primary alcohol if you only take palladium. But if you taking palladium with barium sulfate and sulfur, then what will happen? It will not allow the aldehyde to get converted into alcohol. So the process will stop here and it will result in the formation of aldehyde only. So for the preparation of aldehyde, we are taking the palladium over barium sulfate and sulfur, which are togetherly called as Lindler's reagent or Lindler's catalyst. So let's learn the total process in detail. I am taking here Cl, that means X can be expressed by bromine, iodine, chlorine. I am not taking here fluorine because fluorine shows always explosive reaction. That means the vessel or the container in which the reaction is conducted can cause damage to the person or the instrument in which the fluorine is taken. So for reduction process, I am taking here hydrogen or H2 molecule. You can take H2 or nascent hydrogen here. Why I am taking H2? 2H2 means one is will combine with the chlorine atom, that will go with the chlorine, will result in the formation of HCl, and one hydrogen will bond with the carbon atom of the carbonyl group, resulting in the formation of aldehyde. That means here I am taking the reagent, Lindler's reagent, but not writing Lindler's reagent. I am directly writing the composition. That means palladium over barium sulfate and poisoned by sulfur. So I can directly write sulfur or poisoned by sulfur. For poisoned I am writing star mark. You can also write star mark, or directly you can write sulfur or quinoline. So in this process, what will happen? I am writing directly here H. For reduction process, we always take nascent hydrogen. So we can directly take H, and the H atom will combine with the chlorine, and one hydrogen will also combine with the carbonyl group's carbon. So I am directly taking 2H. That means the reaction will be RCO, this part RCO, and the hydrogen atom, one hydrogen will combine with the carbonyl group, resulting in the formation of aldehyde. And one hydrogen will combine with the chlorine atom, resulting in the formation of acid halide, that means acid halide not, it is hydrogen chloride, it is the hydrogen chloride here. So in this process we can directly produce aldehyde from acid chloride. Here acid chloride we have taken, and acid chloride has the IPC name alkanoyl chloride. So first you should write the process, after that we will go for the example which comes under this reaction. So let's take here example. If put here first 1, n value 1, put here n value 1. After putting the n value in alkyl group 1, so you know that alkyl group has the general formula, that is CnH2n plus 1. That means if you will put here 1, so what will be the result? C1, 2 into 1 plus of 1, the result will be CH3. So CH3, if I will put here CH3, then the name will be, according to IPC name, the name will be ethanoyl chloride, because 2 carbon is present. That what would eth express the total number of carbon, that is ethanoyl chloride will be the IPC name for the compound, and the common name will be, the common name for the compound is acetyl chloride, because it is the acetyl group, and the common name for the compound is acetyl chloride. And acetyl chloride upon reduction through Rosenborn process will result in the formation of acetaldehyde, and along with that it will release the hydrochloric acid. That means it is the process for the preparation of acetaldehyde. But if you think it is not the lower form of aldehyde, that means if we will take here hydrogen, that means it will be, if it will take here hydrogen, that means the n value in the alkyl group becomes 0, though it is the formyl chloride, that means methanoyl chloride will be the IPC name. Methanoyl chloride will be the IPC name for the compound, and you think that the compound will be SCHO and HCl, but this reaction does not occur because the methanoyl chloride is itself unstable. So an unstable compound cannot participate in reduction process at room temperature. So it needs some controlled condition, so which is not maintained in the Rosenborn reduction process. So formaldehyde cannot be prepared from methanoyl chloride by Rosenborn reduction process, which is called as the demerit portion or the negative portion of the Rosenborn reduction. So moving for the aromatic section, but you can put your n value more than 1 to prepare higher form of aldehyde, that means propanyl chloride to propanol, butanol chloride to butanol, different higher aldehydes you can prepare from the acid chloride, but the formaldehyde cannot be prepared by this method due to the unstable nature of the methyl chloride. Now moving for the aromatic section, that means I am taking here benzene ring, and placing for acid chloride, I am taking here C double bond O here, and Cl, RCOCl, aryl part, or here is the alkyl part is C6H5, which is the phenyl part, and the name of the compound is benzoyl chloride. The name for the compound is benzoyl chloride, and the benzoyl chloride also upon reduction can produce, same process will occur, the benzoyl chloride will produce the aromatic aldehyde, that means the benzoyl chloride will produce the benzaldehyde, and one hydrogen from this part will combine with the chlorine part, and the one hydrogen will combine with the carbon atom, that means the resulting compound will be benzaldehyde. It is the formula for benzaldehyde, which can also be prepared by this Rosenborn reduction process. In this way, we can prepare the higher form of aldehydes, including the benzaldehyde, from the acid chloride or benzoyl chloride. It is the benzoyl chloride here. It is the benzoyl chloride. In this process, we can easily prepare the aldehydes only, but we cannot prepare the ketone because ketones are divalent in nature, and ketone's functional group is always located at the middle part, but the functional group we are using for the preparation of aldehyde are the terminal carbon or terminal functional groups. That means they are located at the end of the carbon chain, and the end carbon chain containing functional group, or if the functional group is located at the end part of the carbon chain, it cannot be produced a divalent functional group, because divalent functional group always produces divalent functional group type organic compound, and the functional group we are taking for the preparation of aldehyde here are the terminal carbon containing functional group. So what will happen here? It will not result in the formation of ketone. So it is the only method or the exclusive method for the preparation of aldehyde only. So moving for the next part, that means the Stiffness reduction portion, which is the second method for the preparation of aldehyde only. So the second one is Stiffness reduction. So in Stiffness reduction, what happened? The nitriles or alkane nitrile, or you can say they are nitriles, or you can say they that cyanide, undergoes two successive reaction steps. That means the first step, what happened? The reduction occur. That means in the first step, what happened? Stannous chloride over hydrochloric acid react. After that, the resulting compound undergoes acid hydrolysis, and after the completion of reaction, the two process also, or the two-step reaction here, involve the formation of only aldehyde, because nitriles are the terminal carbon containing functional group. So what will happen here? It will result in the formation of aldehyde only. So how the aldehydes will form, we will know through reaction and mechanism here. So you should write the basic part first. After that we will move for the detailed process. So moving for the reaction first. So how the reaction occur? I am taking here the cyanide, that means RC triple bond N. I have opened the structure for your better understanding. So RC triple bond N, and here what will happen? The cyanides will undergo reduction process. In first step, what will happen? SnCl2 upon HCl will react. This part, hydrogen part, will react with the cyanide, and the pi bonds, 2 pi bond, out of the 2 pi bond, because in cyanide, what do you know? In cyanide, the first bond is sigma bond, and the rest 2 bonds here are pi bonds. So 2 pi bonds are present here. So out of the 2 pi bonds, 1 pi bond will undergo dissociation or fission, or we can say that heterolytic fission, because the atoms are non-identical to each other. So what will happen here? And the double bond will be present here, and one bond will move towards the nitrogen. Why one bond will move towards nitrogen? Because nitrogen atom has maximum electronegativity power, due to which the displaceable electron present over the nitrogen atom will move towards the present between the carbon and nitrogen will move towards the nitrogen atom, resulting in the formation of negative charge over nitrogen and partially positive charge over the carbon atom. So in which the due to dissociation of double bonds, or due to dissociation of one bond, what will happen? The carbon and nitrogen will lack their one valency, and due to lack of one valency, the hydrogen atom released by this hydrochloric acid, or I am directly writing it here H2 or 2H you can write here. I am directly writing here 2H. So what will happen? The hydrogen will go to carbon atom and nitrogen atom, resulting in the formation of, what will happen here? the resulting compound will be like this, and the name of it is the cyanide or alkane nitrile pad here. Alkane nitrile will produce imine. This is the imine part. This is the imine. Imine will be produced after the reduction of cyanide through stannous chloride and hydrochloric acid, and the imine, what will happen? I have told the two-step reaction will occur, and after that it will undergo acid hydrolysis, and upon acid hydrolysis, what will happen? The water part will dissociate the molecule, and the acid part will act as catalyst here, and what will happen? The two hydrogen of the water will combine with this part. For your better understanding, I am rotating this part, but in mechanism some different thing occur which we will learn in later. So NH and H2 will result in the formation of NH3, which is the basic part here will be released, and the carbon will lack here two bonds, and the two bonds will be established between the carbon atom and oxygen atom. So the resulting compound will be aldehyde. You can clearly mark that at CH, and this oxygen part will come to the will come for the carbon atom to satisfy the valency of carbon, and NH will combine with the H2, resulting in the formation of NH3. That means the resulting compound will be RCH. RCH. I am just opening the part RCH. That means here H present means H is present can be at the top position or at the bottom position. So the double bond will combine with the oxygen. That means it will result in the formation of aldehyde along with the NH3. That means it is the aldehyde portion which was the aim for the reaction, or the aim for the reaction was to prepare the aldehyde. So it is the aldehyde which were needed to prepare. So what happened in the reaction process or mechanism? We will mark first. Before that, you should write the process first. We will go through the mechanism for this reaction. So moving for the mechanism part of this reaction. So before going for mechanism, we will understand the mechanism of the reaction through example. So I am putting here for cyanide, what I will write here, we are going for the mechanism of Stiffness reduction. So for the reaction occur, first I have to write the total reaction. That means we know that alkyl cyanide, for R in here, for R I am taking here CH3 and C triple bond N. This is the methyl cyanide. It is the methyl cyanide or acetonitrile. It is the common name also. There are two types of common name here, methyl cyanide and acetonitrile. They are the widely used common names for this chemical. So acetonitrile is the common name for the compound, and the IPC name, you know that IPC name for cyanides is alkane nitrile. So here functional group carbon gets included in the IPC name section. That means the name or function or the IPC name for the compound is ethane nitrile. Ethane nitrile is the IPC name for the compound. So IPC name for the compound is ethane nitrile. So through first step, that means SnCl2 upon HCl reaction results in the formation of, and the two hydrogen comes from this hydrochloric acid. So what will happen? The hydrogen part will go for the dissociation of the 1 pi bond, and it will result in the formation of the imine part. That means here imine is produced. After that, this imine will combine. After that, this imine will combine with. So this imine will further go for acid hydrolysis. So for acid hydrolysis, what will happen here? H2S plus. That means the H plus, you know that will go H2 part will go release as NH3 and CSO. That means CH3 CH double bond O. that means C double bond O, CHO, mark again that, CH, this NH will combine with this hydrogen, NH3 will be released, CH double bond O, that means C double bond O H. So this part is nothing but functional group of aldehyde, and along with that the byproduct which is produced is ammonia, and it is the acetaldehyde, that is ethanol. So how this process occurred we will understand through mechanism now. So I am wiping the naming part here, a nomenclature part. I am just taking the ammonia to top side. So what happened first? This reducing agents, what is the reducing agent here? Stannous chloride over hydrochloric acid is the reducing agent here. So in step 1, what will happen, or initially what happened, the stannous chloride part, SnCl2 part will combine with the hydrochloric acid, resulting as it will the stannous chloride will increase its oxidation number, that means SnCl4 will be produced, SnCl4. So SnCl2 will combine, Cl2 will convert into Cl4. So here 2 chlorine is present, and the rest 2 chlorines will come from the hydrochloric acid here. So 2 HCl we take. What I have told in this section, the 2 hydrogen should be needed for the production of imine. I am repeating this part. 2 hydrogens from hydrochloric acid is needed for the conversion of cyanide or nitrile to imine. So the 2 hydrogen that gets produced, I have told, releases from the hydrochloric acid. So this will occur here. So the 2 chlorine combine with the SnCl2, resulting in the formation of SnCl4, along with the release of the 2 hydrogen ions. This is the first step what occur in this process, and the reducing agent. Now we can mark clearly that here what happened, SnCl2, in SnCl2 the oxidation number obtained is +2. You can mark that how +2, because chlorine has the oxidation number -1 according to the rule, that means group 17 elements, all the group 17 elements has the oxidation number that is -1. So 2 chlorine atom has the oxidation number -1 into 2, and for stannous we are taking X. So the X value here will be +2 because the charge over the compound is 0. So solving for the X value, we get the X value here +2. So the SnCl2 part, similarly SnCl2 contains the +2 oxidation number for stannous, and in SnCl4 the stannous has the oxidation number +4. So you can write that in SnCl2 the oxidation number is +2, and in SnCl4 the oxidation number 14 is SN4+. So +2 gets converted to +4, that means extra 2 number of electron gets released from this part. So 2 electrons get released from the compound, from the atom, so resulting in the formation of 2 electrons in the reaction mixture. So what are the new reactants here produced? 2H plus and 2 electrons are produced from the reducing agent sections. So in the next, moving for the next part, that is the actual reactant part. What is the reactant here? Acetonitrile or methyl cyanide or ethane nitrile. I have told the names here before. So here what will happen? The methyl cyanide, that means CH3 triple bond N. In this case, you know that nitrogen has maximum electronegativity than the carbon. So the one pi electron pair will move towards the nitrogen, resulting in the formation of negative charge over the nitrogen. Similarly, due to loss of electron towards, or due to movement of electron towards the nitrogen atom, the carbon atom produces positive charge. That means what will happen here? The electron released from the conversion of stannous chloride to stannic chloride will come to this part and will combine with this electron, will come to the carbon atom. Due to the positive charge over the carbon, the electrons will come to the carbon atom, and similarly at a time 2 negative charge or negative charge will develop both over nitrogen as well as the carbon atom, that means the imine pad or imine derivative pad will possess both negative charge. Negative charge over nitrogen is due to its maximum negativity, and negative charge over carbon will be due to the electron released by the second step. So what will happen here? In this case, what will happen? The acetonitrile pad will convert C double bond N, and negative charge gets developed over the carbon atoms and the nitrogen atom respectively, because here one bond if moved to nitrogen atom, so 2 electron will be possessed by the nitrogen, and here also 2 electron is coming to carbon, so carbon will occupy the 2 electron. That means in this way both the atoms possesses electron. So due to presence of electron, the positive pad, because positive charge always attracts negative charge, similarly the reverse thing occur here. So what will happen here? And so due to presence of negative charge over the carbon and nitrogen, the hydrogen atom gets attracted towards the both atom. That means here 2 hydrogen is present, so the 2 hydrogen will come towards the carbon and nitrogen. That means, so what will happen? Due to presence of negative charge both over carbon and nitrogen, the 2 hydrogen will come to 1 for carbon and 1 for nitrogen and gets bonded to that to satisfy the valency. So what happen here? The product is CH3CH, because 1 H comes to this carbon pad and 1 H will go for nitrogen, and double bond is present already here. So NH, this is the imine pad what I have told, and the imine pad, this is the imine pad here. This is the imine pad, and the imine pad, after this imine pad, what I have done or what we have done, the acid hydrolysis occur. So for acid hydrolysis, now I am moving the reaction like this, and for acid hydrolysis I am adding H2O over H plus, that means any acid. So H plus pad will combine. That means here also again what happen? What happen here? So what happen here? We know that nitrogen has maximum electronegativity. So negative charge or the pi electron or displaceable electron again transferred to the nitrogen atom, resulting in the formation of negative charge over that, and similarly positive charge or partial positive charge develops over the carbon atom. In this way, what happens? The water has 2 ends also, H plus end and one OH minus end. So H plus end will go to NH part and result in the formation of what I am writing. Again write this structure. So CH3 CH, and the bond will get displaced towards nitrogen due to development of negative charge over that. One hydrogen negative charge will attract the positive charge, that will result in the formation of NH2, and what will happen here? This OH pad will go to the CH pad, that means OH. I am writing OH as open like that. So it will produce like this. This pad is nothing. I am writing this pad from the water section. So what happen here? Also the nitrogen has maximum negativity, and this is the amine derivative pad. So what will happen here? It will also try to take the sigma electron pair towards itself, due to which what will happen? The oxygen from the OH pair will donate the electron to the carbon atom, and due to development of negative charge over the nitrogen atom again, what will happen? The positively charged hydrogen will go to the NH2 part and resulting in the formation of NH3, and finally the carbon will lag its 1 valency. Along with that, what will happen? The hydrogen will also lag due to dissociation of bond. The hydrogen will go to the here. What will happen? The plus charge will develop over hydrogen, and the hydrogen will move to NH2 and result in the formation of NH3, and finally double bond will be established between the carbon and oxygen. So what will be the product here? CH3, what I am writing? CH3, C, double bond O, and H. It is the acetaldehyde, nothing this compound, and the hydrogen part will go to this part and will result in the formation of the byproduct, that is NH3. In this way, we can learn the mechanism section for the Stiffness reduction. So these are the 2 exclusive methods for the preparation of aldehydes only. So if you will put here C6H5 C6H5. That means if you will put your aryl group, you can also find its imine part. Here also. I am going for the benzyl diet preparation section. If you will put your aryl group part, that is C6H5 part, this compound will be produced. Similar reaction mechanism will be followed, and it will result in the formation of, what will be the product of the reaction? It is the benzyl diide here. It is the benzyl diide along with the same byproduct, that is ammonia. This process will also go in this mechanism. So first you should write. After that we will go for the important part of the whole section. You should write first. So the name for the compound is benzonitrile. It is the benzonitrile part. Benzonitrile part. It is the imine part, and it is the benzyl diide part. You can easily learn this benzyl diide portion. I am completing completing benzyl diide along with the benzyl diide part. Aldehyde along with the benzyl diide part for a better understanding. So now I am telling you one reagent which is universally used, divalase. One reagent is there which can directly convert all the acid halide as well as cyanides directly into aldehyde, which is divalase. Divalase. What is divalase? Divalase is an universal agent which directly converts acid halide as well as nitriles directly into what I have told, acid halide RCOX to aldehyde, and R C triple bond N continuous mark I am placing will directly convert it to aldehyde through this reagent, that is divalase. So what is divalase? Di express here diisobutyl. So diisobutyl means butyl has the formula CH3CH2. CH2CH2, it is the butyl group. For isobutyl, one carbon will move towards the second carbon. That means the second carbon here, it is the isobutyl part. And diisobutyl means here we will place here 2. So it is the diisobutyl part. And diisobutyl, it is the diisobutyl part. Al for aluminium. So aluminium, diisobutyl aluminium, and hydride, this is the hydride part. So diisobutyl hydride is the part which can easily convert all the acid halides and cyanides directly into aldehyde. So it is the universally used reducing agent for the direct conversion of acid halide and cyanide to their respective aldehydes. So this class we mainly studied about the preparation of aldehyde only. In the coming class we will learn some more portions from the preparation section. So if you like the lecture, subscribe our channel, share this channel with your friends. Thank you.